Hi students, this is Sivakumar, 10th Standard Mathematics, chapter number 1. In chapter number 1, so far we have completed up to exercise 1.4. Now, exercise 1.5. We are going to study about composition of functions. Okay, look at the definition. Here it is. Let the function f from a to b and the function g from b to c. Here a, b and c are sets. Be two functions, one is f, another one is g. Then the composition of f and g denoted by g composite f. In short form we can say g dot f. A small circle, no, it is an operation like addition, subtraction. So how to read g composite f, otherwise we can say g dot f is defined as the function g dot f of x that is equal to g of f of x for all x belongs to the set A. It's a definition of a composition of two functions. Generally, f dot g is not equal to g dot f. It's in general for any two functions f and g. So, in general, composition of functions is not commutative. If they are equal, we can say commutative. So in general, not equal, how to read? How to say not commutative. Then suppose three functions f, g and h. In that case, composition of three functions is always associative. Look at that, associative. F dot g dot h equals f dot g dot h. So once again, f dot g dot h, g and h inside the brackets. Here f dot g inside the bracket. So f dot g dot h, they are always equal. So we can say composition of functions is always associative. Okay. Now we can get into the exercise. Exercise 1.5, problem number 1. Using the functions f and g, only two functions. We have to find f dot g and g dot f. At the same time, we have to verify f dot g and g dot f are equal. We have to verify. Not show that what is given. We have to verify whether they are equal or not. Totally 5 subdivisions are there. Subdivision number 1. We are asked to find out f dot g and g dot f. How to find f dot g? Introduce x always, that is equal to f within bracket write g of x, that is equal to write f once again. What is inside the brackets? G of x. So g of x can be replaced by x squared, that is equal to, what's the function outside the bracket? F. So outside the bracket f alone. Okay, go to f. Here it is. Here x, that x can be replaced by a bracket. X can be replaced by a bracket. Minus 6 right as it is. So what should be coming inside the bracket? The x squared has to come over here. That is equal to x squared minus 6. Now g dot f, introduce x. G right as it is, f of x inside the brackets. G, that f of x can be replaced by x minus 6. Now outside the set of brackets, you have g. What's the function outside the brackets? G. Now go to g. Here it is. The instead of x, you have to introduce brackets. Square right as it is. So inside the bracket, you have to write x minus 6. Okay. X minus 6, if it is a whole square, no, you have to apply a minus b whole squared formula. A minus b whole squared formula, you know very well, a square minus 2ab plus b square. Which one is a? X, that is a. And this is x. 6, that is b. I write the formula for your reference. A minus b the whole square, a minus b the whole square equals a square minus 2ab plus b square. Come on, a that is equal to x. A that is equal to x, b that is equal to 6, b that is equal to 6. Formula please, a squared minus 2ab plus b squared. That is equal to x squared, 2 into 6, 12, 12 into x, 12x plus 6 squared, 36. Look at that, let it be number 1 and number 2. 1 and 2 are equal or different? Different, obviously. This is x squared minus 6, this is x squared minus 12x plus 36. So from 1 and 2, it is verified that f dot g is not equal to g dot f. Now second subdivision. F of x that is equal to 2 by x, g of x 2x squared minus 1. Okay, now we can find f dot g. Introduce x. So f within brackets you have to write g of x. F. The g of x can be replaced by 2x squared minus 1. Now outside the bracket you have the function f. So go to f, 2 by write as it is. The instead of x you have to introduce bracket, otherwise you can directly write 2x squared minus 1. That's all. Okay, this is LHS. Let it be number 1. Now RHS. I write LHS over here. Now RHS. Even in this problem I write LHS, RHS. In RHS you have to find g dot f. Introduce x. So g within brackets f of x, g, that f of x can be replaced by 2 by x. The function outside the bracket, that is g, here is g, we have 2x squared minus 1, 2, instead of x I have to introduce bracket, square right as it is, minus 1 as it is. Inside the bracket you have to write 2 by x. That is equal to 2 right as it is. 2 square is 4 divided by x squared minus 1 as it is. 2 4s are 8 by x squared minus 1. Let it be number 2. From 1 and 2, it is verified that f dot g is not equal to g dot f. Now subdivision number 3. F of x equals and g of x equals. F of x equal x plus 6 by 3. G of x is 3 minus x. Now we can find f dot g first. F dot g, introduce x. F within brackets write g of x. F as it is. The g of x which is inside the bracket, now that can be replaced by 3 minus x. Now outside the bracket what have? F is the only function. Go to f. Here it is. The x should be replaced by, so x should be replaced by bracket. Others and all you have to write as it is, plus 6 by 3. So inside the bracket you have to write 3 minus x. That is equal to, now you have to eliminate the bracket. So 3 minus x as it is, plus 6 divided by 3 equals 3 plus 6, 9. These two can be added. 9 minus 6 by 3. Let it be number 1. Now g dot f. Introduce x. G. Write f of x inside the brackets. G as it is. That f of x can be replaced by, what is f of x? X plus 6 by 3. Okay. Now what's the function outside the bracket? G. Now go to g. 3 minus. That x can be replaced by brackets. So inside the bracket what you have to write? X plus 6 by 3. It has to be simplified. That is equal to 3 minus x plus 6 by 3. Minus x plus 6 by 3. We can take LCM. What is LCM? 3 is LCM. We just cross 3 3s are 9. Minus, this is common, isn't it? Minus into x, minus x. Minus into plus, minus 6. That is equal to 9 minus 6, that is equal to 3 minus x divided by 3, that is number 2. First equation 9 minus x by 3. Here RHS second equation 3 minus x by 3. They are different from 1 and 2. It is verified that f dot g is not equal to g dot f. Now subdivision number 4. F of x equals g of x equals f of x equals 3 plus x. This is x minus 4. 3 plus x, x minus 4. First we can find f dot g. Introduce x. F. Within bracket you have to write g of x. F. The g of x can be replaced by x minus 4 equals. Outside the bracket we have f. Go to f. Here it is 3 plus, write as it is. That x can be replaced by brackets. Inside the bracket what you have to write? X minus 4 equals 3 plus into x plus x plus into minus 4 minus 4. So x write as it is 3 minus 4, that is equal to minus 1. Let it be equation number 1. Now RHS. This is LHS. Even in subdivision number 3 have to write LHS, RHS. This is LHS, now RHS. We have to find out g dot f. I mean g composite f. Introduce x, g. Within bracket you have to write f of x, g. Inside the brackets we have f of x. That f of x can be replaced by 3 plus x. We have the function g outside the bracket. So go to g. Here it is. That x can be replaced by bracket minus 4 as it is. Inside the bracket you have to write 3 plus x. 3 plus x minus 4. X write as it is. 3 minus 4 minus 1. From 1 and 2. It is verified that f dot g is equal to g dot f. So far we have proved f dot g is not equal to g dot f. This is the only problem. F dot g and g dot f are equal. That is composition of functions is commutative for this problem. Okay. For other subdivisions and all we have proved what we have proved. F dot g and g dot f are not equal. Not equal means not commutative. Equal means commutative. So last subdivision number 5. Subdivision number 5. F of x equals g of x equals f of x 4x square minus 1 1 plus x. 4x square minus 1 1 plus x. Listen. Find out f dot g. Introduce x. F. Within bracket you have to write g of x. F. Inside the bracket you have g of x. That can be replaced by 1 plus x. Now outside the bracket what is the function? F. Go to f. 4 write as it is. The x alone should be replaced by bracket. Square write as it is. Minus 1 as it is. So inside the bracket what you have to write? 1 plus x. That is equal to 4. Here you can apply whole square is there. Now you have to apply a plus b whole square formula. This is a, this is b. Okay. What is the formula? A square plus 2ab plus b square. Then minus 1 as it is. I write the formula here. A plus b whole square formula please. A square plus 2ab plus b square. A that is equal to 1, b that is equal to x. Here 1 square, here 1, here x square. Because a square 2ab plus b square equals 4. 1 square is 1. 2 into 1 into x, 2x and x square minus 1. Multiply by minus. 4 ones are 4. 4 into 2x, 8x. 4 into x square, 4x square minus 1 equals. Arrange them in order. First highest power of x. What is the highest power of x? X square. So 4x square write as it is. No other x square term. Then x term. We have only one x term. What's x term? 8x. Finally the constant. We have two constants. One is 4. Another one is minus 1. 4 minus 1 that is equal to 3. That's all. That is number 1. Now this is LHS. Now RHS. We have to find out g dot f. Introduce x. G. Within brackets f of x. G. That f of x can be replaced by 4x square minus 1. 4x square minus 1. The only function outside the brackets g. So go to g. 1 plus x, that x can be replaced by brackets. 1 plus brackets. Inside the bracket what I have typed? 4x square minus 1 equals 1 plus into 4x square plus 4x square plus into minus 1 plus 1 minus 1 get cancelled. We have 4x square. Let it be number 2. Look at that. 1 and 2 are not equal. From 1 and 2, it is verified that f dot g is not equal to g dot f. So problem number 1, all the 5 subdivisions are over. I will be teaching problem number 2 in the next video. Thank you, children.